CNT125, we are looking at Chapter 12 on WANs. Beginning part of the chapter is some basics about WANs just to kind of get ourselves sorted and situated for the technologies coming. So let's talk about that in this podcast. Reminder, WAN is really a connection between usually LANs. So it's a long distance connection usually between two different LANs maybe that a company would have. You have the Harrisburg branch of a company and the Pittsburgh branch of the company, and you want to connect those two. That connection between them would be a WAN connection. The technology or method used usually depends on the business needs and sometimes even what's available in that area. Certain technology might not be available, so use plan B kind of thing. And if we take a look here at the next picture, I know this is very generic, but just trying to get you the idea of really, you might have branches of a company and the WAN technology is what's connecting them. And I use a cloud here because it's really up to the provider on making the connection from A to B for you. Just kind of a little concept there to kind of keep straight. Differences between WANs and LANs. If we take a look down through the first category here, LAN is really just basically a small geographic area connecting nodes in that building, if you will, at that site. Meanwhile, a WAN, using routers and switches and modems and that sort of gear, is connecting networks, the Harrisburg office to the Pittsburgh office over a wide geographic area. That's the goal of a WAN. Both of them use the same protocols, layer 3 and higher. So IP, TCP, DNS, DHCP, all that stuff, layer 3 and higher, are the same between them. Down at the bottom layers, layer 1 and 2, they're going to differ. Different topologies, sometimes different media, different connection technologies, that sort of thing. These are going to differ. LANs are usually operated and owned by the company that uses them. So my tax consulting company, my LAN is my equipment, hooking together my nodes, if you will. Meanwhile, a WAN is usually operated by a carrier, ISP, and I'm renting a connection from them to connect my Harrisburg office to my Pittsburgh office kind of thing. And I'm running into things like AT&T, Verizon, Comcast, that sort of thing. WAN site, that's an individual geographic location or endpoint connected by a WAN. So again, my Harrisburg WAN site, my Pittsburgh WAN site, those would be the two places that I'm trying to connect together. And the WAN link is the connection between them. So the WAN link connecting my Harrisburg site to my Pittsburgh site, if you will. And here there's just showing you the difference between a LAN. I'm really usually just routers and switches to connect together my nodes. Meanwhile, a WAN is connecting together my branch offices, maybe to the main office, the Miami main office, or something of that nature. They give us a couple terms here that we might run into. DTE, DCE, and modem. DTE, data terminal equipment. This is the customer's endpoint device on the WAN. So this is kind of the connection between the WAN and the LAN, if you will. This might be a router kind of thing, connecting our LAN to their WAN. Meanwhile, the DCE is the carrier's endpoint device to connect for the WAN. So this might be an actual modem of some sort that they're giving us to connect our network to their WAN connection. So the DTE a lot of times is my customer equipment, maybe the router or firewall at the edge of my network. Meanwhile, the DCE is the kind of thing the provider would be giving us, maybe the modem or some sort of device like that to connect our gear to their gear. And they remind us here, modem, that's your modulator, demodulator device, translating signals, whether it be analog to digital or different frequency bands, that sort of thing. To modulate the connection from maybe our site to their site or our technology to their technology. So they're showing you here real quick, internet connection, ISP infrastructure, a modem that they would be giving us, whether it be DSL or some other type of gear. This is still theirs, connecting to our DTE, like a router, to our LAN. So just kind of a couple terms that we run into a number of times when dealing with WAN technologies. Different categories of WAN connections. We have dedicated lines or virtual circuits. So let's take a look at these real quick. Dedicated line is just that. It's a dedicated line to our site. For the most part, not sharing it with anybody else. It's private for us. Private dedicated connection. It's going to be more expensive, but again, I'm not sharing with anybody else, and I'm getting that exact bandwidth. Things like dial-up T1, T3, Sonnet are all examples of dedicated lines. Meanwhile, a virtual circuit, this is a WAN connection that logically appears to be a customer to be dedicated, but can be literally a path through the carrier's network, the carrier's cloud, if you will. Things like frame relay, X25, ATM are all examples of virtual circuits, virtual circuit technology. So when we talk virtual circuits, we also have permanent virtual circuits and switch virtual circuits. So if we look at permanent virtual circuit, again, I don't own all of the gear between A and B, but the provider is mapping me a path through them, and the permanent virtual circuit it's mapping me a consistent path through their equipment from A to B. So the connection is established before any data is transmitted, and therefore all the data is going to transfer on that path through the network. And the idea is if everything's going a dedicated path, we should have limited delay, things should get there in order, etc. And here we go. Example would be something like a frame relay, which we'll talk about later. Our switch virtual circuit connections are established when parties need to transmit and basically shut down when they're done. You could almost think of this as like a phone call. When I make a phone call, a circuit gets established from A to B. We talk, we transfer information, and when we hang up, that circuit is basically unhooked and free for somebody else to use. Same kind of idea here with a switch virtual circuit. Something like an ATM would be a technology using switch virtual circuits. Two different approaches to moving data through networks, circuit switching and packet switching. Let's take a look at circuit switching real quick. Circuit switched, connection established between the two nodes before anything is transferred. Bandwidth is dedicated to that connection and remains that way the whole way through the data transfer until it's terminated. All the data is going to follow that path from A to B. So again, it's kind of everything's in order, follow the leader. Things should get there in a timely manner and should not be mixed up. Things should be arriving in order. And this is very similar to how your telephone call, a telephone circuit is handled, circuit switched. So here I'm using a telephone example, but through all the switches, a path is made and all the data follows that path from A to B during the course of that call. That's a circuit switch technology. Here's another picture showing you a circuit switch through the series of switches. Everything follows this path to here. Everything follows this path back. All predictable. Meanwhile, packet switched, data is broken into packets before it's transmitted. Each packet contains the destination address, sequencing number, that sort of thing that we're used to talking about. Packets then can find their own path through the network from A to B. And the advantage here is if we do have any sort of outage, the packets can try to kind of go around the outage or the break and keep going from A to B. When they do reach the destination, that node needs to reassemble them. It's going to read the packet headers, put them back in order, and get things back in position, if you will. A lot of our data networks run packet switched. And here's showing you packets going this way, packets going this way, all moving through the network. LANs are pretty much always packet switch connections. Meanwhile, WANs can be circuit switched or packet switched, depending on the technologies that you're dealing with. So just kind of keep those two sorted out in your brain. Let's come back to the next one and talk troubleshooting.